Okay, in this lecture, we will be solving exercises on the previous lecture, Fundamentals of Hypothesis Testing. So we will start by a quick review that Lanoud prepared for you. It was in the previous lecture, but you find it here. And it gives you everything that you need on hypothesis testing, these 2 pages. But of course, if you forgot something, please go back and watch the lecture on hypothesis testing. That was one of the best lectures. Many of you told me that they understood it well. So go back if you forgot some of the things and watch it again, or watch the parts that you think you forgot. Also, we prepared a new hypothesis testing steps for you, in which case maybe the only difference that you'll see is that when you have a t-test, just add with degrees of freedom equal. It will just make it easier for you. And at the end, when you make the conclusion, we thought that it would be better if we write the statement for you, and always you have to choose, for example, there is or isn't. So let's say there is, and then you say enough evidence to support or reject, but let's say you said support, and whenever you support, you take H1, the alternative hypothesis. So let me show you the 4 different situations that you can get as a decision. You know, your claim could be H0 and you reject it, or your claim is H0 and you fail to reject it, or your claim is A or H1, the alternative, and you reject H0. Remember, H0 is the one that is either rejected or failed to reject. You don't talk about rejecting H1. H1, you talk about supporting it. So, or you claim as H1 or HA and you fail to reject H0. Notice that with HA, you always say support, whether there is enough or there is not enough evidence. HA or H1 comes always with the word support. And on the other hand, H0 always comes with the word reject. Either you have enough evidence, there is or there isn't enough evidence to reject. So if you go back here, sorry for this, if you go here, you will see that all of these 4 situations are written here. So for example, I will tell you something. If your claim turned out to be H0, you can immediately choose the reject. So you will take out this and take out also support, because H0 comes with reject, and then you decide whether there is. So if you reject H0, it goes with there is enough evidence to reject the claim H0. And you know, and so on. You will see when I solve the questions today that we are going to use all of these different things when we solve questions. Now the exercises, if you remember, there were about 11, actually exactly 11 exercises in the previous lecture. And today we are going to solve 6 of them. So which ones are we going to solve? We will do problem number 2, problem number 6, problem number 7, problem number 8, problems 10 and 11. So I'm going to solve 6 from the 11 questions, and you need to solve the other 5. But I will give you good news. In the description of this video, if you look down, you will see solutions to all the exercises as a PDF file. So please download it, and you will have typed solutions of all the exercises, the 11. Good. And now we will start by solving the first question that we chose, problem number 2 in the exercises. Okay, let's read it together. The waiting time for customers at Hardee's follows a normal distribution. So waiting time, this is our random variable. You can say the waiting time for customers at Hardee's. That will be your random variable. Follows a normal distribution with a standard deviation of 1 minute. So since this is a general statement, you didn't take a sample to get it. This means that what they are giving us is the population standard deviation. Sigma, it's 1 minute, the standard deviation. Now, they tell you, at the Marina Mall branch, the quality assurance department sampled 50 customers. This means that the sample size is 50, n is 50, and found that the mean waiting time was 2.75 minutes. the mean waiting time was 2.75 minutes. So here you'll say my sample mean X bar is 2.75 minutes. But in this case, I'm not going to write the units, but please you write them because you have more space to write. If you look at the thing here, you see how big is the place where you can write the given. You can write it anywhere here. So for you, it's better to write the given in units so that you always remember what you're solving. But for me, because I don't have space here, I'm just going to not write the given, but we understand it because we're reading the question together. Okay, so sampled 50 customers. Yeah, the X bar was 2.75 minutes. Now, at the 1% significance level, let me even put it in red, 1% significance level. This means that our alpha is 0.01. This is the level of significance. From now on, I will write alpha always in red, so that, because at the end, you know, we will use it when we compute the p-value. And we compare the p-value to alpha. Now, at this significance level, can we conclude that the mean waiting time is less than 3 minutes? So there is a question here that we need to answer at the end. Can we conclude that the mean waiting time is less than 3 minutes? Okay, so let's see if we can answer this question. But to answer it first, read what the question says. It says, can we conclude that the mean waiting time is less than 3 minutes? It means, can we conclude that the population mean is less than 3 minutes? So the claim is it true that mu is less than 3 minutes? This is our claim. Okay, and of course, because it has a strict less than, this becomes our alternative hypothesis. Actually, you can say because it doesn't have an equal sign. Okay, so then you can also remember that this number that you see here is your mu 0. So you'll write 3. Mu 0 is 3. And of course, the type of test. Let's see. What are we? We are given sigma. Once you have sigma, immediately it's a Z test. You don't have to think. Take away T. Good. And what else can we do? Yeah, the claim is H1. So you know what you can do? Write H1 here. It's mu strictly less than 3. This means that it's a left-tailed test because when you have strictly less, immediately it's left-tailed. Okay, if it's strictly bigger, then you do right-tailed. And if it's not equal, then you'll do two-tailed. Just remember this. It's also written in the review that La'nud gave you in the 2 pages before. And of course, the null hypothesis here will be mu bigger than or equal to 3. It's always the complementary statement to the alternative hypothesis. And now, before we do the test statistic, you know what you can do? Your claim is H1. Look careful. Claim is H1. So go quickly down and say that this is the claim. I will take it and delete what you have above it. And always we support the claim or not support it when it's the alternative hypothesis. So take away reject. And then all what you have to do now is to figure out do you choose is or isn't. That we will understand when we solve and find the p-value. So now it's a Z test, a Z test. So the test statistic, Z stat, you remember it was X bar, and of course it's written in the La'nud review, minus mu 0 over, in this case we have sigma. Sigma is known over radical sample size n. What is X bar? We wrote it. It's 2.75 minutes minus mu 0. You can see it's 3. Here you can see it. Divided by sigma is given 1 minute. Divided by radical. What was the sample size? The sample size is 50. And please use your calculator now. You can pause the video because I'm going to just give you the answer. The answer here for Z stat is negative 1.77. Always do this to 2 digits when you do the test statistic, whether it's Z or T. So negative 1.77. All what we have to do now is compute the p-value. P equals, and let's go to the online calculator. So here the online calculator, Let's see. The online calculator, notice it's on the t distribution, but here we have z, so we need to use the normal distribution. So go to normal. Normal is the z distribution. So you will put the z value is the z statistic, the statistic that we just got, negative 1.77, so minus 1.77, and our test was, when we said left tail, take away the other two. So our test is left tail test, and of course you see left tail, always look at the picture when you draw. You will see that the p-value is the area to the left of the z statistic because it's a left tail test. So the p-value now, we got it, it's 0.038. Now we're done with the online calculator, we got our p-value. Now all what you have to do is look again at alpha and compare the p-value to this, to alpha. Alpha is 1%. So the p-value is, it's 3.8%. So it's more than 1%. So it's more than alpha. This means that the p-value is high, it's not low. So this means that we fail to reject H0. Remember, when the p-value is low, you reject. When the p-value is high, you fail to reject. And when we say low and high, we mean in comparison to the level of significance alpha. When we say the p-value is low, it means it's less than alpha. So in this case, we fail to reject H0, and our claim is H1. So this means that since we couldn't reject the null hypothesis, it means that there is a problem with the alternative hypothesis. It's not correct. So you will say there isn't enough evidence to support our claim H1, and you write H1, that the mean is less than 3 minutes. The mean wait time at Hardee's, they told you it's less than 3 minutes, so you'll tell them there isn't enough evidence to support your claim. And so can we conclude, if you go back to the question, can we conclude that the mean waiting time is less than 3 minutes? The answer is no. Okay, great. So we also give you the answer here typed, so you can read it and compare it to our answer. Always compare, okay? And now the second question, which is question number 6. A fast food franchisor is considering building a restaurant at a certain location. Based on financial analyses, a site is acceptable only if the number of pedestrians passing the location averages at least, so we need it to average at least 105 per hour. So this means that suppose that you want to open a fast food restaurant or maybe a coffee shop, whatever. You want to open it in a place where a lot of people pass by. So you can stand there for an hour and count the number of people that are coming. So let's say that you want at least to have 105 pedestrians, those are the people that are walking, to pass by. So here your claim is that it should be, the population mean should be at least 105. So bigger than or equal 105. And so here this means that this is 105 mu0, and because this has an equal sign in it, it is the null hypothesis. So our claim is the null hypothesis. And so we'll write it here, mu bigger than or equal 105. Alternative, of course, it's the complementary statement, less than 105. And because you have less than, you will this will be a left tail test, and so you'll take these two away. And what else can we do before we do the given? See, all of this before the given, before we even looked at the sample. You will go down and notice, because the claim is H0, you will take this and take this out, and you can even write it. Mu0 says H0 says mu bigger than or equal 105. And of course, H0, you either have enough evidence to reject or don't have enough evidence to reject. So you take away the support. And now all what you have to do is to know, is there enough evidence to reject or isn't enough evidence to reject? See how nice it is? We're almost even done with the question. Just we need to always find the p-value and compare it to alpha. So let's continue reading and see what is our sample in this case. Now it says, continue reading. The number of pedestrians observed for each of 40 hours. So what we did is we took a sample of 40 hours. And we counted for each hour what is the number of pedestrians, and then we averaged them. So the mean was 99 people that passed by per hour. And then assuming that the population standard deviation, they're telling you already the population standard deviation is known to be 16. So sigma is 16. Since sigma is known, immediately it's a z-test, take away the t. Very nice so far. Then the question, we have a question, so we need to answer this. Can we conclude at the 1% significance level that the site is acceptable? So now we want to know, is this site acceptable for us to open our fast food restaurant or not? So let's see. So alpha, now remember alpha, we do it in red. Our alpha, the level of significance, is 1%. Here they're telling you 1% significance level. So alpha is 0.01, and put it always in a box. Please always do it in another color, because you know at the end you will compare the p-value to alpha. So keep alpha, it's a special thing here. Okay, so the test statistic, here what do we have? It's a z-test, so you will say z-stat is, and the formula, x bar minus mu 0 over sigma is known, so sigma over radical n. Good. So x bar is 99 minus mu 0 is 105. Remember, mu 0 is always the number that you have here, whether bigger than, equal, less, whatever number you have here in the claim is your mu 0. Don't forget that. Divided by sigma is 16 over radical n, the sample size is 40 hours. So if you compute this, and please always compute it using your calculator and check that I got the right answer, you'll get that z-stat is negative 2.37. Very nice. And now, so our p-value is, this is a z-test, it's left-tailed, and let's put the given here. So first, z-test, so normal. Make sure that you are on the normal distribution. The z is negative 2.37, 2.37, and we have a left-tail test. So look at the p-value, 0.009, and you can see it also here. So because it's a left-tail test, p-value is the area to the right, to the left of the z statistic. So here you'll say p is 0.009. And now we're done with the online calculator. That's all what it's used for. And now alpha is 1%, and p is actually, if you have it as a percentage, it's 0.9%. So it's less than 1%, less than 0.01, which is alpha. And so if the p-value is low, meaning lower than alpha, then H0 must go. So reject H0. And so there is enough evidence to reject the claim. So we have enough evidence to reject the claim that the mean number of pedestrians passing by is bigger than or equal 105. So this means that it's less than 105. So the question, can we conclude that the site is acceptable? No. The site is unacceptable. You can say, you can write the site is unacceptable. So you see how nice this is. In real life you can apply it, because suppose you want to open a coffee shop or a restaurant, fast food, whatever, you can do the hypothesis testing and make a decision whether you want to open it in this area or not. Okay, so please see the power of statistics when you solve these questions. And I'm sure that you understand everything that is happening here, because this is a very simple lecture. It's based, of course, on hypothesis testing lecture, and many of you told me that you understood it well. Okay, so the solution, of course, is given here as typed. You can read it if you want. And now let's go to the third question, which is problem number 7. Let's read it together. in order to determine the number of workers required to meet demand, the productivity of newly hired trainees is studied. So let us read and then I will tell you. It is believed that trainees can process and distribute more than 450 packages per hour within 1 week of hiring. So you hire them, and then this is telling you that it is believed. So there is a claim here. We are claiming that those trainees can distribute. So the average they distribute, mu, is bigger than 450 packages per hour. I feel that it's a lot, but this is what the question is saying. So this means that mu0 is 450. Good. And what is this? This is the alternative hypothesis because it doesn't have an equal sign in it. And so you write it here, mu strictly bigger than 450. Even before you write the null hypothesis, since this has a strictly bigger, you know that it will be a right-tailed test. So take these two out. And even before writing H0, you can go down and say that the claim is H1, the alternative hypothesis, mu bigger than 450. And so we take H0 out, and always we either, with H1 you always say support, so you take out reject, but whether there is or isn't enough evidence to support it, that depends on the p-value. Okay, good. So now H0, of course, you write it, it's the complementary statement, mu less than or equal to 450. See how nice this is? You can start and fill out this thing and take things out immediately. Okay, once you write the claim, you can always finish claim and hypotheses and go to the conclusion and finish almost 2/3 of it. See, and now let's read the given. All right, so what is the given here? A sample of 50 trainees, so sample size is n equal 50, observed for 1 hour, yielded a mean number of packages processed of 461. So the mean number of packages is 461 and a standard deviation of 39. Oh, good. So this is for the sample, the standard deviation S equal 39. So what do we know here? We know that sigma is unknown. Sigma is not given. Okay, but don't jump to the conclusion that you will use a t-test. That is not the right thing to do. In order to use a t-test, remember that the distribution has to be normal. So let's see if we read normal anywhere. So a sample of 50 observed, and then what? Are processed of 461 and the standard deviation of 39. And now the question. At 5% significance level, can we conclude that this belief is correct? Okay, good. So this is the thing that we need to answer at the end. That would be our conclusion, and we will make a decision based on it. Okay, so now what kind of test would it be? They didn't mention normal distribution anywhere. And you know what? If you don't know what your distribution is, do not assume that it is normal. You cannot assume it's normal just by yourself like this. So since it was not given, we will assume that it's not normal. So we have a non-normal distribution. The nice thing is that the sample size is big enough, so it's large. You remember you need it to be bigger than or equal to 30. This is 50, so this is nice. So we have sample size large and a non-normal distribution. So in this case, and sigma is unknown because we have S. So if you go back, you will see that here, if you have a non-normal distribution and sample size is large and sigma is unknown, then you will use a z-test. Okay, so go back and use a z-test for this question. So here we will use a z-test and take out the t. If it was a normal distribution, you would use a t-test. Okay, but it's not given, so you cannot assume it's normal. Let's see now. The test statistic, since it's a z-test, you'll say z-stat is equal to, of course, it's x bar minus mu 0 divided by s here, sigma is unknown, divided by radical sample size n. And so x bar is 461 minus mu 0 is 450. Remember, mu 0 always here, and you get it from any number that you have here in the claim. And divided by s, the sample standard deviation is given 39 over radical sample size. We took 50. 50 trainees. And so if you compute this, you will get, let me check. This is problem 7. So I computed this before. It's 1.99. Remember, for Z or T stat, you do to 2 digits after the decimal. So now we have 1.99 and it's a Z test. So you have to do normal distribution. And it is already, good, already on normal. And now you'll put your Z. It is 1.99. And what kind of test do we have? Right-tailed. So here you'll say right tail. And look at the p-value. You have it already. I want also for you to see the picture. See the p-value in this case, because it's a right tail test. It's the area to the right of the Z statistic. So P, you can write here, P is equal to 0.023. Okay, this is what? It's 2.3%. So this is 2.3%. And our level of significance, here they told you, at the 5% significance level. So let me write alpha here. Alpha is 5%, 0.05, and put it in a box. Okay, so now you tell me, is this number bigger or less than 5%? We know it's 2.3%, so it's less than 5%, 0.05, that is alpha. So this means that the p-value is low, because it's lower than the significance level. And if the p-value is low, H0 must go. You must reject it. So take this out, and because you're rejecting it, you'll say there is enough evidence to support the claim H1. Okay? Because you rejected H0, this means that there is evidence to support H1. Good, because they are complementary statements. If you reject one of them, it means that the other is supported. So there is enough evidence to support the claim. Our claim was that the trainees can deliver or process and distribute about 450 packages per hour. So this means that our conclusion would be, can we conclude that this belief is correct? You will say, yes, this is correct, or this belief is correct. Very nice. See how you are making decisions now. All right. So this is this question. We finished it. This is the solution typed, and now we go to the next question. Ultra Health Clinic claims that the average waiting time for a patient is 20 minutes or less. You need to read the whole thing, yeah? So the average waiting time for a patient is 20 minutes or less. So in the clinic, they're telling you that if you come to the clinic, when they tell you to wait for the doctor, you will wait 20 minutes or less. Okay, so we want to see if this is true or not. Personally, I always wait more than 20 minutes. But let's see, maybe this clinic is telling the truth. So let's see. What's given, before what's given, the claim, they say the average waiting time for a patient is 20 minutes or less. Since this is not based on a sample, you assume that this is something about the population mean, because they're giving you this in general. So they're telling you that the mean waiting time is at most 20 minutes, so less than or equal to 20. This means that this is H0, the claim, because it has an equal sign in it. And mu 0 is what? It will be 20, of course. You take the number that you have here. Okay, so far so good. So now write H0. So here you'll say mu less than or equal 20. H1, which is the alternative hypothesis, will be mu bigger than 20. And you can, because you have a strictly bigger, you know that this will be a right-tailed test. And so you take these two out, and you will go down. And remember, your claim is the null hypothesis. So this is my claim. And so I know that I will choose reject. And so not that I'm rejecting it, but that when I write the statement for the conclusion, I will say either I have enough evidence to reject, or I don't have enough evidence to reject it. Okay, good. We're almost done, believe it or not. We didn't even write any of the given yet, and we were able to finish like half of this page. All right, so now read with me. It says a random sample of 15 patients, so I have sample size is 15, shows a mean wait time, so their X bar is, sample mean is 24.77 minutes, with a standard deviation of 7.26 minutes. So this is the sample standard deviation, 7.26 minutes. And now assume that the waiting time is normally distributed. Why are they giving us normally distributed? Because the sample size is small. It's less than 30. So you must see a normal distribution somewhere. And so because of this, you know that you will be using a t-test. T-test because sigma is unknown and the sample size is small. Of course, you have a normal distribution in this case. So we are using a t-test in this case. And now we will write the test statistic. It will be a t, so t stat is equal. The previous one was also a t, yes? The previous one, no, the previous one was, yeah, it was a big sample size, but they didn't tell us it was normal, yeah. And sigma was not known. We had the sample standard deviation. Okay, good. So in this case, t stat is, again, x bar minus mu 0 over, now we have sample standard deviation S over radical n, and x bar is 24.77 minus mu 0 is 20 divided by S is 7.26 over radical sample size 15. Okay, and again, please do this on your calculator and make sure that you get what I have. So in this question, we have the t-stat is 2.54 to 2 digits if you compute it. Check, please. Okay, good. And now the p-value. P equals, let's go to the online calculator. And notice it's on normal distribution, but I have the t distribution now. So you'll come here and click on this. Okay, click on students t. See that students t distribution, and now you will put the t-stat here. So the t-stat in this one is 2.54. We just computed it. 2.54. The degrees of freedom. Oh, something important. I told you that whenever you have a t-test, write the degrees of freedom on top of it. So, or next to it. So make it like this big, and once you choose this, you will say also df, degrees of freedom equals, and then you look at your sample size, it's 15, so it's just 15 minus 1, which is 14. So you can say this will be a t-test with degrees of freedom 14. So now you will say the degrees of freedom 14, and it's what? It's a right-tailed test. Remember, this was a right-tailed test. So you'll put right-tailed, and we got the p-value 0.012. And I will show you the picture. It's a right-tailed test, so the p-value is the area to the right of the test statistic. So we will go here and write the p-value is 0.012. And now our online calculator already served us. Okay, and now we compare. Of course, this has two parts. The first part is at the 5% level of significance. Good, so I need to write it here. Alpha is 0.05. And please write it also in the given, 0.05, and it's in part A. So maybe part B has something else, but write everything in the given. Does the sample support or contradict the clinic's claim? So this sample that we took and we found the sample mean and sample standard deviation, whatever we get from this sample, does it go along with what the clinic is claiming? Remember, the clinic was claiming that the waiting time, the mean wait time for people is 20 minutes or less. And now we're checking if what they're telling us is correct or not. So the p-value is 1.2%. You're comparing it to 5%. So of course it's less than 5%, which is the significance level alpha. Since the p-value is low, it's lower than alpha or less than alpha, H0 must go. And so we reject H0, and so there is enough evidence to reject the claim. And what is the claim of H0 is mu less than or equal to 20. See how nice it is? Now we need to answer the question. Does the sample support or contradict the clinic's claim? So remember, the clinic's claim is H0, the null hypothesis, and we rejected their claim. So this means that their claim or this sample is contradicting their claim. So does the sample support or contradict? You'll say the sample, let me write it here big, the sample, or this sample, let's say this sample, the one that we chose, this sample contradicts the clinic's claim. The clinic's claim. So you can tell the clinic that I'm sorry, but my statistics is showing me that what you're claiming is not accurate. Okay, good. Now what is part B? It says, is this conclusion sensitive to the choice of alpha? Which conclusion? Of course, that the sample contradicts the clinic's claim. So look here. What is P? P is about 1.2%. Yeah. Now, what happens if we have chosen alpha to be 1%? If you wanted to do it on level of significance 1%, then notice that this will be bigger. The p-value is going to be bigger than alpha. So let me write it like this. And if it's bigger, what will happen is that you will fail to reject the null hypothesis. And so here you will say isn't. So we don't have enough evidence to reject the clinic's claim. And so here you will say that yes, the conclusion is sensitive to the choice of alpha, because if we choose alpha to be 1%, then the claim of the clinic is supported by this sample. Okay? This is very important. You see, if you change the alpha, the level of significance, you can change the conclusion of the question. See how good it is and nice and easy even to solve? Okay, so this ends this question. Here you can find the typed answer. And now we go to the, this would be the fifth one that we're solving today. We have just one question after this and we'll be done. So let's read it together. The average weight of a package of rolled oats is supposed to be at least 18 ounces. So the average weight is at least 18 ounces. So mu is at least, so bigger than or equal 18 ounces. So when they say at least, it means at least 18 means 18 or more. That's why you write it mu bigger than or equal to 18. Since this has an equal sign in it, this is the null hypothesis H0. And of course, mu0 is 18. And you can also write H0, write it here, mu bigger than or equal to 18 ounces. And so the alternative hypothesis will be mu less than 18. And because we have strictly less, because we have less, this will be a left tail test. So you take these two out. And because your claim is H0, you will go to the end, as I told you, and you'll say, this is my claim. Write it, of course, better to write it now, mu bigger than or equal to 18. And of course, it goes with reject. And so you will take this and this. And now you're waiting to know whether there is enough evidence to reject or there isn't enough evidence to reject. So we need the p-value to do that. Okay, so let's read. A sample of 18 packages, so we have sample size is 18 packages. What it says shows a mean of 17.78 ounces. So this X bar is 17.78 ounces with a sample standard deviation of 0.41. This is for the sample. So S, this is not sigma, this is S. So 0.41 ounces. Since sigma, we still don't know. But because the sample size is small, it's less than 30, we must have a normal distribution in order to be able to solve this question. So we must read somewhere that it's normally distributed, as you can see here. Assume that the weights of these packages are normally distributed. Nice. You can put a happy face because you expected it and it was there, that normal distribution. And in this case, of course, you can say sigma is unknown because we have the sample standard deviation and the sample size is smaller than 30 and we have a normal distribution, so we use a t-test. And because we're using the t-test, we're going to first take out the z, and remember, for the t-test, we also write the degrees of freedom just to make our life easier. And so since the sample size is 18, degrees of freedom will be one less, so 17 degrees of freedom. And now we can compute the z statistic. And then, okay, if you want, you can read the question before we do it. At the 5% level of significance, this means that we're taking alpha equals 0.05. Okay, and so at 5%, so let me write alpha also, as I told you, write it also with the given 0.05, and this is in part A, and put it in a box, please. Okay, so now what is the test statistic? It's a t-test, so you'll say here t-stat is equal to, just let me check something. Yeah, I wrote t-stat here. Okay, so t-stat is x bar minus mu 0 divided by, in this case, of course, sigma is unknown, so S over radical n. T always comes when sigma is unknown, remember that. And the normal distribution, of course, but you will never put T and then put a sigma in the formula. Only with Z you put sigma. Okay, so, and Z also can have an S. You remember, if you have a non-normal distribution with a big sample size and sigma is unknown, then you use a Z test. We solved the problem like this today, in this lecture, I mean. So now X bar is 17.78 minus mu 0 is 18 divided by S is 0.41 over radical sample size is 18. And as always, please compute it. So if you compute it, you will get negative 2.28. Check it, please. So t-stat is negative 2.28. Now the p-value, p equals, and now we have left-tailed degrees of freedom 17, t-test, and t-stat is negative 2.28. So let's go to the online calculator. And is it on the t already? Yes, it's on the t distribution. We always make sure. And the t value for us is negative 2.28. Degrees of freedom, 17. And it's a what? It's a left tail test, so you put left tail. And you get the p-value 0.018. Of course, it's a left tail test, so p-value is the area to the left of the test statistic t. Let's write it here. It will be 0.018. This is like what? 1.8%. Okay, so now let's see. Compare this to the alpha in part A. Alpha is 5%. So, of course, 1.8% is less than 5%, which is alpha. Okay, so this means that the p-value is what? It's low, lower than alpha. And so H0 must go. So reject H0. Very nice. And since you rejected H0, you'll say there is enough evidence to reject the claim H0. So since there is enough evidence to reject the claim, what does this mean? Well, what was the claim? The claim was that the average weight, if you want, I'll highlight the claim. The average weight of a package of rolled oats is at least 18 ounces. And then we found that we have enough evidence to reject it. So the question is, in A, does the true mean meet the specifications? The answer is no, it doesn't. Based on the sample that we took, it doesn't meet the specifications. So I can say it doesn't meet the specs, let's say specs. So the answer to this is done. And now let's look at part B. What is part B? What type of error could be made in this case? Describe it in the context of the problem. Okay, now for the type of error, remember you have two types of error, type 1 and type 2. I will just quickly remind you of type 1 and type 2 errors from Le'anoud's summary. So here, a type 1 error happens when you have a true null hypothesis that you reject. Rejecting something true. Of course, this thing, when I say something, I mean the null hypothesis. If the null hypothesis is true and you reject it, you will say that I made or I committed a type 1 error. And a type 2 error is when you have a false null hypothesis, but you fail to reject it, or you do not reject it. So when you do not reject something that is false, that's an error, of course. Okay, so these are the two errors that we have. Now, remember from our question, the one that we are solving now, we ended up doing what? Rejecting H0. So the only kind of error that we can make is what? It's type 1 error. So this means that it could have been that H0 is true, but we rejected it. One thing I want to make sure that you remember also for type 1 error, remember, your maximum allowable probability of making a type 1 error is alpha, the level of significance denoted by alpha. So here you can say this thing here, alpha is the probability of type 1 error. And let's remember, what was alpha for the question that we're solving? So I'll just go back to the question and just remember what we did. Alpha is 5%, okay? They gave us 5% level of significance. So this means that, where should I write? Okay, I'm going to write here, but please pay attention. I will write in this space. So alpha is the probability of type 1 error. And in this case, we are choosing this alpha to be 5%. So you can say alpha is the level of significance, or you can also say it's the probability of type 1 error, of committing a type 1 error, of making a type 1 error. The probability is alpha. Okay, so the probability of type 1 error is 0.05 or 5% in this question. So there is a chance of 5% that what? Look what we've done at the end. We rejected H0. So what's the probability that we did something wrong? 5%. But what is the wrong thing that we've done? It could have been that H0 is true, it's correct. And what was H0? That the average weight is at least 18 ounces. Okay, there is a chance of 5% that this is true. This here is true. Or you can say this statement is true, which is the null hypothesis. And we rejected it by mistake. So the probability that this could happen is 5%. And the probability that it couldn't happen, of course, is 95%. That's why we think that it's, in this case, we are rejecting H0 and we are like 95%, you can say 95% confident that we rejected a false null hypothesis. But there is always this 5% chance, because alpha is 5%. If alpha was given to be 1%, then you would have said there is a 1% chance that we will make a type 1 error. But in this question, since it's given at 5%, you'll say there is a 5% chance that we committed a type 1 error. So here, what type of error? You'll say type 1 error. Type 1 error could be made in this case. That's the answer to the question that you see here. It's type 1 error that could be with a chance of 5%. So let's see, type 1 error with a probability of 5%. Describe it in the context of the problem. So you can say there is a 5% chance that the mean or the average weight of the packages of rolled oats is at least 18 ounces, and that is correct, but we ended up rejecting it. Okay, because it could happen. Okay, there is always a place for error in any statistical hypothesis testing. So in this case, there is a 5% chance that the oats were had an average weight of at least 18 ounces, but your statistics made you reject a true null hypothesis. Okay, I think that this is more than enough explanation. I hope that you understood it by now. And this is the typed answer, and this will be our last question. Okay, so, and I don't understand, why is it always that the last question is long? Why couldn't it be just a question without parts? That's what you're thinking, right? But actually, it's a very nice question. You will like it. And the parts are quick. So it says, a statistics practitioner measured the IQ of 10 randomly sampled students. So sample size is 10. And found X bar, so the average for this sample, the sample mean is 103 points on the IQ test, and the sample standard deviation is 17. Notice we have a small sample size and sigma is unknown. So immediately you know that you will use a t-test if you read somewhere that this is a normal distribution. You need that your random variable to be normal. Okay, let's see. Does it say anywhere? Yes, assume that the IQ scores are normally distributed. See? So put a happy face here because you expected it and it was there. So definitely we'll use a t-test, and degrees of freedom, I take this out first. Degrees of freedom will be 10 minus 1. So you take the sample size and subtract 1. So it will be 9, the degrees of freedom. Okay, and now what would we do? We wrote everything. So part A, is there sufficient evidence? So there is a question. Let me highlight the question. It's asking you, is there sufficient evidence at the 10% significance level? This is not a very good, it's a weak, I mean, when we solve it, there will be, if you remember, let me show you Le'anud, what she tells you, yeah? Here, this is alpha on this axis from 0 to 1. So at 10%, you see here it says weak evidence. Anything between 5% and 10% will be weak evidence. It's not very significant. But here we're choosing alpha equals 0.10, and we know that it's not a very good thing to choose. Usually the best thing to do is to choose alpha 5% or 1%, and then you see where your p-value is. If your p-value, this will be the p-value here or here or here, then strong evidence. If the p-value is here and alpha is 1%, then overwhelming evidence, highly significant. But you see, for 10%, the one for this question, yeah, but we're going to use it anyways. But I'm just telling you that it's not a very good significance level. So the question is, so alpha, first write it. Alpha is 0.10 because it's 10%, and this is for part A. Okay, good. So now what is the claim? Let's see. Is there sufficient evidence to conclude that the population mean IQ is less than 110? So the claim is mu is less than 110, and because it's doesn't have an equal sign in it in the claim, this is the alternative hypothesis H1. And so, and mu 0 is this, 110. So you'll write here 110 for mu 0. And our alternative hypothesis is what's given. It's the claim. So you write it here, mu strictly less than 110. And so the null hypothesis will be bigger than or equal to 110. And because we have strictly less, it will be a left-tailed test. Okay, and you will go to the end and say H1 is given as the claim, and it is mu less than 110. And of course, with H1, you always take the word support. And now, yeah, so now we do what? We have test statistic. We need to find the test statistic. Let's do it in green. So this is a t-test. So this would mean t-stat is equal to, and it will be what? Of course, x bar minus mu 0 divided by here s over radical n. And so x bar is 103 minus mu 0 is 110 divided by s is 17 over radical n is 10. And if you compute it, I will tell you, you will get negative 1.30. Negative 1.30. So this here is our t-stat. And now time for the p-value. So the p-value is, and let's go to the online calculator. Okay, the online calculator is here. And it's on the t, yes, we need the t distribution. So we will put it there. So it was minus 1.30, minus 1.30. And the degrees of freedom, remember, degrees of freedom is 9 because the sample size is 10. So we put here 9. And it is a left-tailed test. So keep it on left-tailed. It was left-tailed in the previous one. So the p-value is 0.113. Okay? And now, let's see. What was alpha in part A? Alpha is 10%. So, by the way, what is this as a percentage, the p-value? This is 11.3%. Of course, this is bigger than 10%, 0.10. It's bigger than alpha. And so because the p-value is high, if you want, it's not low, it's high, so you fail to reject H0. Okay, so take this out, and you know that this will mean there isn't enough evidence to support the claim. So the statistics practitioner doesn't have enough evidence to support his claim in part A. So is there sufficient evidence at the 10% level to conclude that the population mean IQ is less than 110? No, we don't have enough evidence because we failed to reject H0 and our claim is H1. So when you fail to reject H0, this means that kind of H0 is correct, so H1 is not correct. So there is not enough evidence to support the claim or the alternative hypothesis. So no, there isn't. You can say, okay, keep it as no, but you understand what I mean by this. And let's look at the second part, and this is where I want you to pay full attention. Repeat part A, assuming that you know that the population standard deviation is sigma equals 17. So they're making it easy for you here. They're telling you, let me choose this color. They're telling you now you have the population standard deviation. So instead of S, you have sigma. Sigma, and it's the same number to make it even further easier for you, because this means that you don't have to make a lot of changes when you do the computations. But if it was different, of course, you'll have to do things over again when you do the test statistic. Notice if sigma is given or sigma is known, then it will be a z-test. And this is what will go away. Pay careful attention to this. Yeah, sigma is known, and of course you have a normal distribution of the IQ scores, and the sample size is small, so you know that you will use a z-test in this case. And so everything else stays the same in the computations, except when you get to the test statistic, what you will do is you will do Z stat. And if you think about it, it will be x bar minus mu0 over sigma over radical n. But it will be also negative 1.30 because all the numbers are the same. We took sigma to be the same as s. Okay, that's just to make the question easier for you to solve. Okay, so now your Z stat is negative 1.30. So let's use this to compute the p-value. So from the Z stat, we compute the p-value. The p is going to be what? So we will go to the online calculator. We're almost done. So in the online calculator, since we're using the Z, it's the normal distribution. And you will come here and put again negative 1.30. And it's a what was it? Yeah, a left tail test. So you put left tail and look at the p-value. So you can also read it from the graph. I prefer you to look at the graph because it's telling you more. It's reminding you of what is the p-value. So in this case, the p-value is 0.097. And compare this to 10%. Which one is bigger? This is as a percentage. What would it be? It's let me just write the 9.7 better so they're not overlapping. This is like 9.7%. This is less than 10%, 0.10, which is alpha. And so remember, here we are answering the same question but using the population standard deviation. We found that in this case the p-value will be less than alpha. So the p-value is what? It's low, lower than alpha. So h0 must go. So in this case you will reject h0, and so you'll take this out and you will say there is enough evidence to support the alternative hypothesis because we rejected h0 and our claim is h1. So there is enough evidence to support the researcher or the statistician's hypothesis or claim that the average is less than 110 of the average IQ of the students. So this the repeat part A, when they tell you here the answer either yes or no, in this case it's yes. Is there sufficient evidence at the 10% significance level to conclude that the population mean IQ is less than 110? Yes, in this case, because we found that we reject H0 and our claim is H1. So there is enough evidence to support this claim. Now, the last question is, let's use this color. Explain why the conclusions produced in parts A and B differ. Why is it that I got a different conclusion here than here? Okay, what do you think is the reason? Is it because of the sigma and s, that sigma was given here and s there? Not really. I mean, in some sense, yes, but because sigma made us use the z distribution or the normal distribution, but when we had the sample standard deviation, we used the t distribution. So of course, because you have used the t distribution in part A with degrees of freedom 9, and you used the z or the normal distribution in part B, you expect that you will get different answers, of course. Okay, and so this answers the questions. The explanation is because we are using different distributions in A and B, and so don't always expect to get the same answers. See how nice? This is a very nice question, by the way. And it's typed here. And finally, impossible is possible. لا شيء مستحيل. The Emirates, الإمارات. Thank you for watching. Please solve the other questions that I left. You know, there were 11 exercises and we solved 6 in this lecture. So you still have 5. Solve them, please, and you can check your answers because I will post in the description of this video the answers to all the 11 questions or 11 exercises. And thank you for watching. Please like this video, subscribe to my channel if you haven't done so yet, and put the notification button on. And as always, take care.